actual historical data. So on the 7th of June on that Texas site, as you can see, the gray bar represent the wind speed of the day. In the daytime, the wind speed are pretty high in the afternoon, especially after like 2 p.m. And what doesn't show here is the direction of the wind. So I just put some notes here. So the northwestern wind dominates the entire day, but between 1 and 3 p.m. The wind turns to northeastern. Yeah, but it's like still pretty like a high wind speed. And you can see the other curves. They represent different solar, like different type of solar energy output. The red curve behind represent a non-interrupted tracking, like a full tracking with no interruption. The green one represent the east-facing solar irradiation, like a fixed tilt towards east at 30 degree.
Yep.
Yep. The yellow one to the west, 30 degree, and the purple one, is it purple or dark gray?
Horizontal.
Yeah, represent the horizontal.
Yeah, that's a perfect example of what tracking gives you, which is a very flat production curve, no bell curve.
Yeah.
Yeah.
Yeah. That's like a very cloudy day. If you have like other days, it might look very
spikes.
Very tricky.
Yeah.
But anyhow, let's keep looking. So this is the curve for Skyline 2. Yeah, and you can see there's like a red dashed line that represent the wind speed threshold. So luckily, no wind speed go above that line. So the Skyline 2 energy output perfectly matched the uninterrupted tracking.
Right.
Yeah, so there's no energy loss in this day.
So the second y-axis on the right, that's the wind speed?
That's correct, yes. But that has been transformed to 1 hour, so it's not 22, it's like 14 point something.
Yep.
Yeah. Sky Smart with slightly lower critical wind, like a stow wind speed, but still okay in this situation, no energy loss. But let's check the other one. So this is the Model A, which is 16 meters per second stow wind speed. So after 3 p.m., the wind speed has reached its stow wind speed threshold. So the tracker are very likely to get stows towards towards west, luckily. So the sun, the sun is also on that side.
Yeah.
So you see there are some energy losses, the blue shades, but not too much. But what happened for this one?
Whoa.
Yeah, so this
that doesn't look good.
That doesn't look nice. So because I just mentioned between 1 p.m. and 3 p.m. It's eastern wind. So yeah, the tracker has to stow towards the east.
Right.
Yeah, so you have like a huge, how to say, a loss happened in that hour. And let's see the worst scenario. This is 12 meters per second at 45 degrees stow. So you have like 2 hours stow at 45 degrees towards east. And you can see the loss is like a much with a 45 degree tilt.
Right, it's a really graphic representation of the benefit of a high stow wind speed capability.
Yes.
Yeah.
Yeah. And if we gather all these hourly data together, we come up with with this table. Yeah.
My gosh, that's a lot of dollars.
That's right. So we always say for a solar farm, every 1% means a lot.
Yes.
Yeah. So as we can see, there's like a lot of energy losses based on like on Model ABC. Well, inevitably, Skyline 2 and Sky Smart have some minor losses as well, but that only translate to a few thousand. That's not as the same magnitude as the other models, which can up to 260,000 per year.
Wow.
Yeah.
So what scale megawatt farm would that be?
This is the 100 megawatt.
Oh, so for a 100 megawatt farm, selling into the wholesale market at $28 a megawatt hour, up to $260,000 lost.
For the first year.
Yeah, for the first year. Okay. That would pay for a lot of extra trackers and other equipment.
Exactly. If you
Yeah.
if you do it like translate back to like a